Let's look at setting up a Grab Interactable for Unity and its OpenXR plugin. We're going to create a simple cube to be our grabbable object. So I'm going to make a 3D object cube. I'm going to make this cube red. So I'll grab my red material and throw it on the cube. And once again, as is so often the case with Unity, I've made an object and I have no idea where it went in the world. If we check up on the transform, you'll see that it went essentially to the center of my viewport here. That's not where I want it, so I'm going to reset it and it'll appear in the center, in the origin point. So I'm going to shrink this down and then let's hover it over top of this table. The other thing that we're going to need for this to work is that we want it to have not only a collider, which it has naturally, but we also want it to have a rigid body component. And so a rigid body allows us to make this subject to gravity and all the other things that we want. Since this particular rigid body is going to be picked up and moving around, the collision detection might be useful to have set as continuous, which is just going to more actively update when it's bumping into things and when it's not. Since it's going to be attached to a VR controller, it can move quite fast potentially. Then we're going to add a component called the XR Grab Interactable, and I'm just going to start typing grab and that'll bring it up. The XR Grab Interactable is what Unity uses to tell itself that this object is grabbable by our XR controllers that have interactor components on them. And by default, this is already going to work, but there are a couple of things you could potentially want to change just for future reference. If we want only certain interactions to be possible, you can create layer masks, so that not everything in the world can interact with some of these objects, like maybe only the right hand or maybe only the hand after it's achieved a certain condition or whatever. You can create layer masks that basically say like only this type of thing is allowed to interact. But for now, we'll leave that default. The other things that might come in useful, the movement type has a couple of choices. If you find that you are wanting the object to not pass through other solid objects, but you want it to kind of get stuck or even fall off the hand if it kind of whacks into the table, you'll find that under velocity tracking, which is sort of the most physics-oriented of the three. Kinematic is kind of like it does that, but only in relationship to the hand and not everything in the world. And then instantaneous is more like just like mouse cursory, where it just like follows you wherever it goes. If your object is jumping around and looking kind of choppy, you can also look at these smoothing settings to check. They're a little less performant, of course, but they're going to look a lot better to smooth position and smooth rotation. All right, let's give it a test and see how this works. All right, I'm headed over to my object. I grab it, and now it is attached to my hand. Because I have instantaneous set, it can pass through, and if I let it go, it falls back down. Here's velocity tracking. You can start to see some of that jitter and how it's freaking out even in relationship to the hand controller object. One of the reasons velocity tracking is looking so jittery is because we have a collider on our cube that is our hand controller. So that sort of stand-in controller we made a while ago comes with its own collider, which we do need a collider. But this object is colliding with that collider as if it's not able to pass through it. But if we change that collider to be a trigger, now Unity will still know the controller has a collider on it, but it's not freaking out so badly when the velocity tracked object is touching that controller's collider, because the collider is no longer considered for physics. It's just a trigger for like, is it touching something or not. I didn't change it yet on this controller, and as you can see, the object does not want to go inside the controller, and it's kind of freaking out when I'm asking it to. Whereas on the right controller, it's working much more as expected. Other unintended consequences here of the default settings, we still have these ray interactors on our controller, which means we can grab this object from way across the room using the force. That could be cool if you want it, but if you want this to be a less magical experience, if you want it to be like, no, I really have to walk up and touch that thing, then we need to get rid of this ray interactor as a possibility. The other thing that you might notice is on your joystick, you can also move the object forward and back along that ray. And I would not say I would want this by default either, but it is the default setting. So if we want this to be more like an object that we just pick up in the real world, you have to be touching it and you can't do any kind of special force magic to it. We've got a couple of things to change in the editor. So that will bring us back to our XR origin, and we're going to be looking at our controllers. So these are under XR origin and then under camera offset. So the controllers have a group of components by default. There's the XR controller action based that has all of the input actions by default. And then there are the ray interactors plus a couple of helper components that make the line. So, you know, if you wanted to change how big the line is or what color the line is, or, you know, things like that, the XR interactor line visual and the line renderer are places you can make those adjustments. If you want to keep the line but not let us use the joystick to move it back and forth, that's under anchor control. So we could just tick that off, and now you could still pick it up at a distance, but it would jump to your hand and the joystick wouldn't move it back and forth along the line. If you don't even want it to jump to your hand, if you want it to be more like I picked it up from a distance, but it just stays way over there on the table while I move it around, that's force grab. So we could turn that on or off. But if you don't want any line at all, if you're just like, I want to pick things up with my hands and that's it, we can't keep this component. And it's not even like we could just uncheck it and throw a different component on and get our pick, because the different component we're going to throw on would complain if we try to add the other component in question is called the XR Direct Interactor, and if we click it, it'll say I can't add that because it's already got a ray interactor. So unfortunately, we don't get to have our cake and eat it too. We've got to remove this component. So I'm going to click on the three dots and remove component. I'm going to do the same to the line renderer because it's now irrelevant. And it's going to say, oh, I can't because there's something else that needs it, and that's the line visual. So we're going to remove that first, and then remove the line renderer, and it'll stop complaining. So now we've got a controller that takes input, but it doesn't actually interact with anything. And that is the point where we could add our direct interactor back in. So the direct interactor has a lot less options than the line interactor does. And that's fine because we don't expect it to do quite as much. But I will point out that there are a number of options, including you know, what layer mask can it interact with. So maybe there are things that this controller can interact with and things that it can't. And that's a good way of separating the two. You can set up where exactly it attaches on the game object of the controller prefab. And other things like audio events or even haptic events where the controller can buzz when certain things happen. And then one more thing that we need on this for the direct interactor to work, it needs a collider. So we're going to add a sphere collider onto this controller. And I'm just going to shrink it down to maybe 0.1 so that we have information that the direct interactor can collect that it is touching something that is grabbable. And we'll make that sphere collider a trigger because we don't want it to keep the box out. We just want it to pass right into the box but know that it is being collided with. So we're going to hit play to test this. And now my left hand should be a direct interactor with no ray. My right hand hasn't changed yet, so that's still the old ray interactor. We pass this into the box, press the grab button, and aha, I've got the object in my hand. And then if I let go, I can throw it. This one still works the way it used to. So if we wanted one hand to do one thing and one hand to do the other, we're cool. Otherwise, we should reproduce everything we just did to the left hand onto the right hand if we want both hands to function the same. So with this collider, the reason we choose trigger is that way we can pass the collider right through and into the object and it doesn't knock the object over, but Unity still knows that it's colliding with the grabbable object, and that way when we click the grab button it will activate the grab interaction. If you were making like a physics thing where you just wanted to be able to knock the objects off the table, then we would want a collider that was not a trigger. Now, I've been demoing in headset for a little while because it's a whole lot easier to test what you're doing when you interact with objects when you have the actual input devices that you're intending to author to. But I recognize that if you are authoring on a Mac or you just don't have a headset, then we will be using that device simulator. And so that's still in our hierarchy, and if we want it back, we just click on it and enable it in the inspector. Now when I hit play, we will be using those slightly complicated controls So now we have to go back to using those somewhat complicated controls that Unity offers. So I'm holding Shift and right click and moving the mouse up to bring my camera up to sort of normal height. Now I'm holding Shift and using W to move forward and go over towards the table. I'm going to bring my head down so I can kind of see what I'm doing. And then here is my controller. So I can use my scroll wheel to move it forward. And when it's touching the object, G is grab. And yeah, I've grabbed it. So I can test and make sure that all of this functionality works just with mouse and keyboard with no headset or controllers at all. It's a little fussy, but you can do it. You know, I wouldn't necessarily try to build like a skee ball game or something doing this, but like, let's see if I scroll and let go of G, I can kind of throw something. It's not, you're not going to get a whole lot of accuracy using this kind of control, but should you need it, this is a good way of testing things that you might not otherwise be able to author at all on a Mac or without a headset. Speaking of throwing, there are some settings on the Grab Interactable component, which you'd find on our red cube, where you see throw on detach is checked by default, but there's also a couple of scale settings, and these allow you to essentially magnify the throwing velocity. People don't tend to throw with their full strength when they've got a headset on and they're holding expensive controllers. You know, they just want to make like the tiniest little movement and get a good throw. So you can turn these up to get whatever effect you want so that the throw feels, you know, not accurate to the real world, but a little bit superpowered so that it feels right in the virtual world.